In the spring of 2018, Bridges led a small coding club with students who attended a therapy clinic in Milton, Ontario. This coding club was a pilot undertaken by Bridges that led to the beginning of the Coding to Learn and Create project, a project dedicated to supporting educators with curriculum and resources so that active participation in coding activities can be achievable for all their students, including those with significant challenges. All too often, kids with learning challenges are being left out of the opportunity to explore, to create, and to express themselves with digital technologies. We wanted to make sure that didn't happen with all of these new engaging activities. Not only is learning to code fun, but coding to learn offers countless benefits, like developing positive social skills and a sense of belonging through communication and collaboration with peers, activating problem solving and critical thinking skills, developing fine motor abilities, or even reinforcing simple concepts like sequencing and patterning. These are all essential skills that will lead to independence and enjoyment in their lives. So for these reasons, we need to ensure their participation. It's actually fundamental to their development. So that spring, our journey began, and we embarked on our explorations with Banjo, David, and Reese.
That's right.
During our activities on day one, we spent a great deal of time introducing our young explorers to the language they would need to understand in order to complete the day's tasks. We provided visuals with text and image supports and reinforced their understanding through conversation, making connections, and active learning. After introducing the concept of sequencing, we practiced creating a piece of code with the group. The goal was to make Cubeto the robot travel from a specific starting point to a target location on the map. Each student was given their own practice control board with pieces of code they could Velcro on. The individual practice boards allowed our explorers to be hands-on during the group activity. The visual supports also remained in front of them so they could confidently attempt the task independently. At one point, Reese appeared to be struggling to recreate the code on his own card, so he was approached with an offer to help. He abruptly brushed off the offer, however, and insisted that he continue on his own. His sequence wasn't mirroring the rest of the group's, and he did appear to be struggling. He was continually staring at the map and the visuals. But we didn't want to create a negative space for him, so we honored his wishes and left him to continue independently. After closer observation, we discovered the reason Reese didn't want help. He actually didn't need any. He wasn't struggling. He was working on a code that had the robot taking a different path than the one we were doing together. We had misinterpreted struggling, with him actually applying independent problem-solving skills. He was stuck on a single piece of code and was trying to use the visuals available to help figure it out. In the end, Reese managed to create, test, and fix his alternate code independently. Throughout each session, each one of our explorers was observed using the supports put in place on a regular basis. This allowed them to be independent and successful critical thinkers and problem solvers. They also continued to challenge themselves well beyond our expectations and surprised us a number of times with their discoveries. It was definitely a great learning experience for all of us. But that was just the beginning. We took what we learned from our coding club in Milton and we got to work, designing, creating, and adapting resources, strategies, lessons, materials, and tools to support teachers who, like us, believe that all students can be meaningfully included in learning to code and coding to learn and create. Be sure to follow our progress and join in the fun.